Hi, my name is Paul Pasolka, Ivy Masters Learning Center at ivymasters.com. Today we're going to look at Test 3, Section 3, number 20, which reads, in triangle ABC, the measure of angle B is 90 degrees, BC is 16, AC equals 20. Triangle DEF is similar to triangle ABC, where vertices DE and F correspond to vertices A, B, and C respectively. And each side of the triangle DEF is 1/3 the length of the corresponding side of triangle ABC. What is the value of sine F? Well, if you know that trigonometric functions are simply a ratio, sine, cosine, and tangent are simply a ratio, and in similar triangles they have the same ratio of sides, then there's very little work to do here. I'll illustrate it, but very little work to do here. If we make our triangle, it tells us that angle B is 90 degrees. So granted, that's not a perfect triangle. And let's say A and C, and it says BC is 16, AC is 20, and then DEF is similar, but it's 1/3 the length. So granted, figure not drawn to scale, and DEF and DEF. Okay, so in other words, this would be 20 over 3. This would be 16 over 3. Now, one thing that you should know for these triangles is, let's say you look at this problem and you're like, crap, I don't know what to do. Well, the most common triangle is a 3, 4, 5 triangle on SAT. So if it says sine of some angle and you have to guess, you'd want to guess 3 over 5 or 4 over 5, because those are the two possibilities of sine for a 3, 4, 5 triangle. Same thing for cosine. You guess 3 over 5 or 4 over 5. For tangent, you guess 3 over 4 or 4 over 3. But what you might see is, I'm going to draw one more triangle here. And so anyway, here's the shortcut. If you're looking for the sine of F, it's going to be opposite over hypotenuse. It's going to be the same as the sine of C. Here's your 3, 4, 5 triangle. And if you notice, the triangle ABC is 4 times it. So if you multiply 4 by 4, you get 16, 5 by 4, you get 20, 3 by 4, you get 12. So angle C, let's call this angle, let's call this X, Y, Z. So the sine of F is going to be the same as the sine of Z, 3 over 5, which is the same as the sine of C, which is 12 over 20. And notice if you divide the top and bottom by 4, you get 3 over 5 as well. Okay, there's no reason to, if you did the Pythagorean theorem here, you could solve for the sine of DF, or you could just take 1/3 of the 12, and you see that this side is 4. So it would be, this is what there's no reason to do. The sine there would be opposite, which would be 4 over hypotenuse, which would be 20 over 3. 4 over 20 over 3. But there's no reason to do that. Now, if you needed to, that's the same as 4 divided by 20 over 3, which is the same as 4 times 3 over 20. And that's 4 over 1 times 3 over 20. You could cancel these. That becomes a 1, that becomes a 5. And you could see that you wind up with 3 over 5 again. Thank you for joining us today. If you like this video, click like. You could share it with someone who has trouble with trigonometry. If there's any video you'd like to see shot on any question from any official PSAT or SAT or ACT, you can leave it in the comments. I'd be happy to shoot a video on it. And click subscribe so you don't miss anything. Have a great day.